Good morning, everyone. Let's take a look at polyatomic ions. Okay, so polyatomic ions, let's dive right into it. Polyatomic ions are a group of atoms that are bonded together. They have a charge and they act like a single unit. So I want you to think of it as like a box of cereal. Polyatomic ions are like a box of cereal. Like think about Lucky Charms. Even though there's a lot of stuff in the Lucky Charms, it's one box of Lucky Charms. Okay, so these polyatomic ions are going to look like they have a lot of stuff in them, but they come as a single unit. Okay, and so as they come as a single unit, they're going to only have a single charge. And it's not so easy just to find the charge of them. You actually have to memorize the charge. Okay, so take a look. They are found combined with other ions. So let's take a look here. Sulfate, SO4, you see SO4, and then you have 2 minus. Nitrate, NO3, so this is our box of cereal, and then you have to memorize the charge. Just a negative sign there, -1. Carbonate, okay, and there's the charge right there. So the parentheses just keep the atoms together, and do not change the subscripts inside the parentheses because you wouldn't change the ingredients in Lucky Charms. It's a box of Lucky Charms. It stays just like that, okay? All right, and then one of the things I want you to note is they have similar names. Like you can look here, we have sulfate down here and sulfite. So we have an ATE ending and an ITE ending. So you're going to find that a lot of these are like this, nitrate and nitrite. But if you notice, what is different about them is the number of oxygen atoms we have here. So the different endings just depend on how many oxygen atoms are attached to that polyatomic ion. Okay. The ending, though, doesn't tell us like there's 4 oxygen atoms here, because if you notice, this has an ATE ending, but so does this. But this guy only has 3 oxygen. Okay. Let's keep moving on. All right, so most of the polyatomic ions, they contain oxygen atoms. Okay, so just what I talked about before, you're going to see endings like ITE or ATE. The different endings just means there may be fewer or more oxygen atoms. Doesn't tell you the exact number, though. All right, so here's a list of some common polyatomic ions. I will attach a sheet to your Google Classroom, but you can Google the chart. Here's the chart here. So they have different endings, IDE, ITE, and ATE, okay? You also have things like hydronium, dimercury, ammonium. Here we have acetate, cyanide. We can go over to this side, hydroxide, peroxide, sulfite, sulfate, hydrogen sulfate, okay? These are things that you memorize. If you go into chemistry, you memorize them, okay? You guys, you just go to the chart. You just look at them up on the chart. All right, so formulas and the names of ionic compounds with the polyatomic ions. Or we call this ternary ionic compounds. Diving right into writing the formulas. Okay, so ternary ionic compounds are compounds that contain 3 or more elements. Right, they're neutral, just like the binary ionic compounds we looked at before. So we did ionic bonding with binary compounds, and then we did ionic bonding with transition metals. And so just like the goal was before, we want to find the lowest ratio of cations to anions that yield a neutral compound. How do we do this? In our formula unit, previously, if we had like a subscript of a 2 and a 4, we would simplify that, right? Okay, so we're going to do the same thing here. Let's just look at some formula units here. This is calcium. We have calcium carbonate here, zinc acetate, silver nitrate, and this is sodium sulfate. All right, so to write the formula, you're going to use the crisscross method. First, you're going to find the charge. So we want to write the formula for lithium phosphate. So I give you the name, tell me the formula. So lithium, on your periodic table, you just find your periodic table, Google one. Lithium has a +1 charge. And then phosphate, okay, that's a polyatomic ion. I'm just going to go to my chart. For example, I have this chart here. I'm going to look at phosphate. Let's see, right here. Here it is. So what's the charge of that? A 3-. So let's go back. I know my PO4 3- has a charge of a -3. I'm just going to do the crisscross method. Remember this? Li has a +1, PO4 a 3-. Okay, I'm going to give this to this guy, this to this guy. Switch the numbers around, not the sign though. So now I have Li 3, and then you can put this in parentheses to separate it from the lithium, PO4, and it's a 1, so we don't have to write it. So there you have it, your answer. So although it looks complicated, pretty easy. Use the crisscross method. Okay, here's the answers here. Okay. All right, so lithium chlorate. Use the crisscross. Use crisscross. Okay, try this on your own. You're going to look up lithium, which we already did, right? And then chlorate, you got to go to your chart. So chlorate, right here, ClO 3-, or ClO 3, and it's a -1 charge. So you write it down, ClO 3, and it has a -1. Crisscross, and tell me your answer. Okay, so if you do the crisscross method, you should get Li is going to take the 1. We don't have to write it. And ClO 3, remember this is one box of cereal. ClO 3 is also going to take the 1. And then just to separate it out, we'll put parentheses. So here is your final answer. Okay, here you go. Here it says the parentheses are removed here because only one chlorate is present. I prefer just having the parentheses, but you can also remove them there since there's only one. All right, example number 2, manganese 3. So look, manganese 3, that's a transition metal. This is the charge, right? The 3 tells you the charge, so that's a +3. Carbonate, go to a chart. What's the charge on carbonate? That's a pretty common one. Carbonate, it's CO3. That's the cereal box, and the charge is 2-. So what are you going to do? Use the crisscross method now and get your answer. Okay, so if we crisscross, manganese is Mn, and let's just write out carbonate CO3. Okay, I'm going to give my 3 to this guy and my 2 to manganese. So it should be manganese 2. And then since I have more than one of these guys, I'm going to put parentheses around it and a 3. There's your formula. Okay. All right, the formula for aluminum phosphate. So go ahead, we have aluminum. And then you go to your chart, phosphate. Phosphate is here. So PO4 is your box of cereal, and then the charge is 3-. So PO4, 3-, PO4, 3 minus. You got to get the charge of aluminum. If you look on your periodic table, aluminum has a charge of +3. Go ahead, you would just crisscross here, and then you might have to simplify. So go ahead, do that now. Okay, so once you have that, you should get answer choice A. So once we crisscross, we get AL. You can't see the answer over there on that other slide. Sorry about that. And PO4, you crisscross the 3's, you would have 3 and 3. But you can factor out a 3 from both, so your final answer would be aluminum PO4. Okay, you don't need the parentheses since there's only one phosphate, but I like it there. So your answer choice was A. What would be the correct formula for cobalt 3 and carbonate? So cobalt, on your piece of paper, write out cobalt. I give you the charge here, +3. And then carbonate, you just go to your chart. Okay, carbonate is up here, CO3 2 minus. Okay, crisscross, and let's see what the answer is. So your final answer will be, we give the 2 to cobalt, the 3 over here. So we have cobalt 2, parentheses, CO3, and we have to give it a 3 down here. So your answer should be, there's nothing here. Your answer should be CO2, CO3, 3 should be answer choice C. Okay, sodium hydroxide. So periodic table, sodium. What's the charge on sodium? So you find the charge on sodium. Sodium is in group 1, so it has a +1 charge. Hydroxide, go to your chart. Hydroxide. There we go. OH minus. Crisscross. This should be an easy one. Okay? And see what you come up with. Okay, so they both have a charge of, one has a charge of +1, one has a charge of -1, just crisscross, and we get this as our formula. And that, my friends, should be your final answer, should be B. Calcium sulfate. Calcium sulfate. So use your periodic table. Calcium is in group 2, so it'll have a 2+ charge. Sulfate, use your chart. So sulfate right here, SO4 has a 2- charge. SO4, 2-. Okay, we're going to crisscross. Should be an easy one. Go for it. Okay, so we crisscross the numbers here. We get 2 and 2, right? Calcium, 2, SO4, 2. But we can factor out a 2, so we should get CaSO4. And that would be answer choice A. Okay, 54. How many nitrate ions are present in the formula of aluminum nitrate? So this is a different question. It says here, write the formula first to find out. So I want to know, how many nitrate ions are there? So like, how many boxes of cereal, how many boxes of nitrate cereals are there? Okay, so aluminum nitrate. We have aluminum. We already know from previous problem, aluminum has a 3+ charge, and nitrate, we'll just get that from our chart. Nitrate, NO3-, NO3-. We're going to crisscross, right? So the 1 over here, the 3 over here. So get your formula, and then you should get Al1. We don't have to write it. And NO3, but we're going to have 3 of them. We're giving this to the nitrate. So here it says, but how many nitrate ions are there in the formula? Well, here's my big box of cereal. Here's my big box of cereal, right? Here's what I want to know. How many boxes of cereal do I have? This number here tells me how many boxes of cereal. So what's your answer? How many boxes of cereal do I have? Okay, the answer should be C, 3. Okay, how many total ions? I want to know. Total cations and anions are present in the formula lithium acetate. So first, let's get the formula for lithium acetate. Li is in group 1. That's a +1. Acetate, I'll just go to my chart. Acetate is up here. CH3COO. And it has a -1. CH3OO. Is that right? Hold on. I don't have these memorized. CH3COO. CH3, I knew it wasn't right. COO, and it's a -1. So that's acetate. All right, so how many, we're going to crisscross, right? So we're going to get Li and CH3COO, and it's a 1. So they both have 1s here. So how many boxes of cereal are here? This is one big box of cereal. How many are here? And then tell me total cations. This is a cation here. And this is an anion. How many total? Okay, if you add them all up, we only had 1 lithium box of cereal and 1 acetate box of cereal. So 1 + 1 will give me 2. Okay, we're done.